There's a lot of disorientation over there. Okay, over here we have when h prime is positive, h is, oops, increasing. Thank you. Is that why there's disorientation? Okay. And when h prime is negative, h is decreasing. And if you move from one row to the other row, you have a relative max on f, or you have a relative min on f, depending on which way you're going. Okay, so if I look at when is x less than negative, well, when x is less than negative 2, is h prime positive or negative? Okay, what about if I pick a number between negative 2 and 1? Negative. And what if I pick a number between, greater than 1? Oops. Okay, what's my answer? Can you do that by yourself? Okay, because you will be by yourself on Monday, all right? No one there to help you. So where are you guys going? Did you guys decide? To bed? Okay.
Probably like Panda Express.
Panda Express? Okay. All right, guys. Most common wrong answer I have on that is going home. I would say it's the wrong answer, but that's what most people say. All right, formula quiz. These are some ideas for your formula quiz tomorrow. Okay, I could just have a random derivative. What's the derivative of cosecant u? And then you would just write negative cosecant u, cotangent u, and don't forget times du dx. Okay. Chain rule, product rule, quotient rule. Please make sure you understand that the derivative of f of x times g of x is the derivative of the first times the second plus the derivative of the second times the first. But the derivative of f of g of x, which is not the same thing as f times g, okay? So I'm going to look a little bit closer at notation. Some of you have gotten away with this, okay? But the derivative of f of g of x, this is a composite function, is the derivative of the outside, leave the inside alone, times the derivative of the inside, okay? And this right here, guys, is the derivative of the inside. So do not add a du dx, okay? Do not add that to this, okay? This right here is basically the du dx. It's the derivative of the inside. Right here, you know, like this right here is a chain rule. When you took the derivative of the outside, it was negative cosecant cotangent. And then you take the derivative of the inside. So the du dx is the exact same thing as the derivative of the inside. So please don't repeat it when you write out this chain rule, okay? The definition of a derivative, there are two of them, do you remember? So one of them is a limit as which goes to 0. H goes to 0, okay? And so you just have this memorized. And make sure you understand that it really is just a slope. So make sure that this sign in the middle is a negative right here. This right here is a number bigger than x, so you have to put x plus h, okay? And then the other alternate definition of a derivative is when x goes to c, right, some point. But this, instead of being f of x plus h, is what? Do you remember? F of x minus f of c over x minus c. You have to have both of those memorized. All right, what's the average rate of change? It's really just the slope. So guys, if you wrote this, that would be correct. Okay, that's not the way I teach you, though. I teach you with f of b. Oops.
What'd you do this time?
All right. So you could have this formula, that would be right, but the formula that I teach you with is f of b minus f of a over b minus a. Guys, does that look familiar to you? Yeah. It's really just y minus y over x minus x, okay? It's the slope that you knew what slope was before you came into this class, and I totally confused you. Okay, definition of continuity, do you remember? Three things must be true. If a function is continuous at x equals c, three things must be true at c. Do you remember? First, f of c must exist, okay? Second, what? The limit as x goes to c of f of x must exist. And then finally, what? Set those two things equal, okay? And you cannot believe how many students know this one and then can't remember this one, all right? So let's look at these three. Make sure, guys, you know the difference between the three. All I'll do is put part of it up and you fill in blanks, okay, for IBT, MBT, and EBT. Critical points happen at in two situations. It's the C value or the X value when the derivative is 0 or when the derivative is what? D and E. Guys, please don't get confused between critical points and relative max and mins, okay? Relative max and mins occur at critical points, okay? But over here, let me just make sure you understand. This is a relative max when the derivative is 0. You guys good with that? This is a relative max when the derivative is D and E. Can the derivative be D and E and you also have a relative max? Yes. Everybody good with that? Make sure you understand that the relative max doesn't have anything to do with the derivative. Okay, it's just a hill. It could be a pointy hill. It could be a curved hill, a smooth hill. Okay, it's just a hill. All right. You guys need to know the notation. When f prime is positive, f is increasing. When f prime is negative, f is decreasing. The definition of a relative max is when I move from f prime positive to f prime negative. That's a relative max on f. Okay. And if I move from the bottom row to the top row, that would be a what? Relative min on f. You also need to know, that's the first derivatives test. You also need to know the concavity test, which is when f double prime is positive, f prime is increasing, f is what? Concave up. And you need to know that these are all synonymous. If I tell you f prime is increasing, you can tell me that f is concave up. Does that make sense? If I tell you f is concave up, you can tell me f double prime is positive. Like, they're all synonymous. They're all meaning the exact same thing. And likewise, when f double prime is negative, f prime is decreasing, and f is concave down. What happens when I move between these two rows? POI. On what function, though? On what function? F. Is everybody good with that? And all these f's can change to a different letter as long as you're consistent. So this could be G, G, G. Does that make sense? Okay, as long as you're consistent about it, then they can all change to a different name. All right. And then relative max, relative min, and POI we talked about. All right, so you're ready for your formula quiz? We'll definitely have that tomorrow. Mean value theorem, people are still having trouble with mean value theorem. I want to talk about this question here. If I have a function, it's a little funky here. They tell me the function minus 1 is x cubed. Guys, all that means is you just solve for the function. Okay, so if you get something funky like that, all it means is you solve for the function. Okay, guys, can you go ahead and put your phones away, please? Like, I don't want to see them. Thank you. Okay, all right, so if this is f of x, and it says, you know what, this function satisfies the hypothesis of the mean value theorem. What that means is, you know those two conditions that have to be true? They're already met. Is everybody good with that? So you don't have to state them again, all right? But since we have a formula quiz tomorrow, let's go ahead and state them, all right? But you don't need to state them for this problem. They're already met. What are the two conditions that must be true for mean value theorem to be applied? First, the function must be what? Continuous on what, though? Very important. On the closed interval. And then the second, the function must be what? Differentiable. But on what? The open interval, okay? And again, let me just make a note. Not necessary for this problem, but it's necessary for your formula quiz. And it's necessary when they tell you, find out if you can apply mean value theorem. And if you can, tell me where the C is. So what they're saying here is you have this function, you kind of know what the function is, right? It's an x cubed function. And they're saying on this x cubed function, from -2 to 4, okay, find those 2 points. So here's a point here, and here's a point here. Connect those points, okay? That's a secant line. Where does the slope of the secant line equal the slope of the tangent line? So what they're saying is find C1 and find C2. Does that make sense? That's what they're asking you to do. All right, do you see that C1 and C2 are really just your x values? Is everybody good with that? Okay, and mean value theorem says the slope of the tangent line is equal to the slope of the secant line at least 1 point. It's not true at every point. So you can't just say a blanket slope of the tangent line is equal to the slope of the secant line. That's not always true. But it is true for at least 1 point, and we're going to try to figure out what that 1 point is. And there may be more points on this one. All right? All right, so how do you set the mean value theorem up? What's my equation? F prime at x or at c is equal to f of b minus f of a over b minus a. Unfortunately, if you just put this, you don't get any partial credit, okay? I do smile. I might give you a check, okay? But you're not going to get any partial credit for this. But if you go one more step, you'll get partial credit. So let me go ahead and write the function here. This function was x cubed plus 1. Okay, so what's this side? What's the derivative? 3x squared. That's it? Okay. What is b in this problem? 4. What is a in this problem? Negative 2. 4 minus negative 2. Guys, if you can write this, there's a lot of partial credit involved, okay? Because what you've done is you've gone from the equation and you've plugged in numbers, okay? And so you're like, you know, if I could just figure this out, I have the answer, okay? So this is a lot of partial credit here. And then what do we need to do here is figure out what f of 4 is. So I go to the side of my paper and I say f of 4 is everywhere there's an x, I'm going to put in 4. So that's 4 cubed plus 1, which is what? Quick.
65.
Thank you. 65. That was really good. And then if I put in f of negative 2, this will be negative 8 plus 1, right, which is negative 7. And if I plug this in, I'll get 65 minus negative 7 over 4 minus negative 2, which is 6. So that's going to be 72 over 6, which is 12. And there's my answer. Any questions?
That's not the answer.
What a great question. Okay, so what should I do then if that's not the answer? What should I do?
Solve for x.
Solve for x. Very good, guys. Please do not stop there. I can't tell you how many students have stopped there, how many times I've stopped you from stopping there, how many times Brant has spoken out, okay? But you need to solve for x. So this is going to be x squared is equal to 4, so x is equal to plus or negative 2, and that's my answer. Any questions? Brant, any questions? Okay, there should be a question here. Guys, after you get your answer, what are you supposed to do with it? Check it. Check it to make sure what? It's inside the endpoints, okay? And guys, mean value theorem guarantees, okay, that if you get a number in between these, that the slope of the tangent line is equal to the slope of the secant line. But it doesn't guarantee that if you get these numbers, okay, that's true. Does that make sense? And so, well, what were my answers? Negative 2 and 2. So what does mean value guarantee? That x is equal to 2. It doesn't guarantee that x is equal to negative 2. Although it might be true, okay, the question is, what does mean value theorem guarantee? And so therefore your answer is only 2. If it's on the endpoints, drop it, okay? Any questions about how to present your mean value theorem answer? All right? Okay, so you've seen this a lot of times. Hopefully you're getting more and more comfortable with it. All right, I need to show you something that confuses students, okay? It's going to confuse you in this unit, and then it's going to start confusing you even more on the next unit, which is, the next unit is like my favorite unit, okay? All right, so concave up like a cup. You good with that? So if I tell you that F is concave up, then F is going to be shaped like a cup. But what you have to understand is that concave up is really just a bend. It's just a bend of your curve, okay? So someone asked last period, they said, is this concave up the absolute value? It's actually not. Like, even though it's like a cup, it's a bad cup, okay, first of all. But second of all, there's no bend in the curve. Does that make sense? Concave up is really talking about your bend, okay? The other thing about concave up is concave up can be distinguishable from increasing and decreasing, because on this side of the concave up F, this function is decreasing. And on this side of the concave up cup, this side is increasing. So if I asked you to draw me a curve that's concave up and decreasing, you would draw me something like this. Does that make sense? You would not draw me, oh, no you wouldn't, sorry. You would draw me something like this, right? You would not draw me the right side of the curve. You would draw me the left side of the curve. Is everybody good with that? And concave up and decreasing, you would, what am I reading this wrong? Concave up and increasing, you would draw the right side of the curve. And it doesn't have to be a huge, like it doesn't have to be the whole cup. I mean, you could just do me a little bit. Does that make sense? But it's got to be increasing, meaning the slope is always positive. And it's got to be the bend. The bend has to hold water, so to speak. Okay? All right. If I ask you for concave down and decreasing, so if you look at the concave down curve, concave down is like a what, guys? like a frown, you actually don't have to give me the whole frown either. So remember, right here, if this were your F graph, this is F is increasing, and over here, F would be decreasing. You guys good with the F increasing and decreasing? Different from F positive and F negative, right? And different from concave up and concave down, okay, increasing and decreasing. So if I asked you for concave down and decreasing, you would draw me something like that. If I asked you for concave down and increasing, you would give me the left side of the graph. Any questions on the bend for concave up and concave down? All right, so I want to make sure that that's clear. And this one, before we get into our new thing today, I want to make sure you understand that if I graph position with respect to time, okay, and I have a curve, what does the slope of this curve represent? Because it's change in position over change in time, right?
Velocity.
Are you guys okay? That is velocity? Okay. Okay. Any questions about that? Velocity or speed? You guys good with that? Okay. Guys, don't make fun of people if they say the wrong answer, okay? I'll do that. Okay. Any questions about that? Okay. That's mostly what I wanted to talk to you guys about. Let's go ahead and, I guess before we get too far into it, let's talk about homework, and then we'll move into our new thing. So homework last night, I had a lot of questions on, I think it was 27, I'm not sure, but these are your problems. What questions did you have?
25.
25? Okay.
Yeah, just like how do you find the x-intercept?
Oh, this one and this one were kind of hard to find, these two. And so you didn't have to find it, sorry. Sorry about that. Okay, sorry, I should have clarified that. I forgot, okay? But here's the thing. When the x-intercept and the y-intercept, I asked you to find them just to help you draw the curve. Okay, so if you if you are trying to find it, it's so hard. Well, that's not helpful to draw the curve. Does that make sense? So you just don't find it. On your test, okay, it'll be not hard. Okay, so FYI. So if you look at my answer key, and I'll post my answer key. If you look at my number 25, see it says x-intercept, and I put too hard, and I just didn't write it, okay? But guys, that's not an acceptable answer for you guys. I'm just letting you know, okay? On your test, it's not going to be too hard, all right? But here was too hard, so I just didn't find it, because it wasn't helpful, okay, to find the curve. But I promise you guys, everything I ask you for on your test is very doable, okay? All right. So this is what 25 looked like, except for the x-intercept, should have been pretty straightforward. Okay, for number 27, you could have actually figured out the x-intercept by just plugging in, like randomly plugging in. If you had plugged in 1, you would have seen that y would be 0. So you could have maybe figured it out by randomly plugging in. But if not, this one was too hard also. But you could draw the sketch. Something about this one that students had trouble with. When you did your f prime graph, did you see that you had no critical points?
Yeah.
Okay, when you have no critical points, that just means you plug in any number you want. You got a free reign on your number line, okay? So I hope, most of you guys did the noble thing and picked 212, but not all of you guys are noble, so I don't expect that, okay? But you should have gotten, no matter what you plugged in, that you had a negative f prime. And because of that, this function is always decreasing, okay? So when you drew this function, it was always decreasing, okay? It did have a POI though. The POI happened at 0 because when you took the second derivative and you put in 0 into your f double prime number line, oh, shame on me, this is not labeled, okay? But into your f double prime number line, you had a POI because f changed from concave up to concave down. So therefore, there is a POI, and so you have a concavity change right at 0 there. Okay, but no slope of 0, just a concavity change. All right, 29 was a little bit more challenging. Did you guys like that one?
Yes.
Oh, was it? Oh, because of the x-intercept. Guys, if you're on your homework ever and you're working on something for more than, I would say like 15 minutes and you're not Brant, I would just go ahead and email me, okay? Just email me and tell me, hey, I'm stuck on this. Can you help me out? Am I doing something? And I'll try to reply as soon as I get to it, okay? Because you shouldn't be stuck on anything for more than 15 minutes, all right? Okay, I'm just kidding. Brant, you can email me too. All right, 2 things I want to point out on this. When you took your f prime, did you notice you had 2 critical points, okay? And both of those critical points happened when you set f prime equal to 0, okay? So slope of 0, superhero. What's happening there? Relative min, max, relative min, horizontal tangent line, right? So guys, when you look at your increasing and decreasing, okay, if f prime changes from negative to positive, what you have is a relative min. If f prime changes from positive to negative, what you'll have is a relative max. And guys, if you ever see increasing, increasing, or decreasing, decreasing, that's where you're going to have like a horizontal tangent line and then keep going. Does that make sense? And so that's what happened right here at 0, okay? So you had a relative min here because you had decreasing then increasing. Then you had an increasing, increasing. Guys, when you have an increasing, increasing, and you have a slope of 0, okay, right here what happens is, you know, you slow down for a bit, you know, maybe you stop to use a restroom or something, okay, and you go back up, okay, so you go back to 0 and you just head back up, okay, everyone, that's why this picture looks like this. This was a kind of a cool picture. Did you feel very satisfied after you did this problem?
I didn't like the way the graph was.
Okay, that sounds racist. Okay, anything else? Okay, so this is what your function look like. Okay, any questions? Is this your last problem? Yeah. Okay, let us go back, and I'll post these solutions online so you guys can take a look at my solutions. Let's go back to calculus containers, and I want you to look at the back of the worksheet that you picked up. These are calculus containers. Okay, and what we're going to do is I'm going to ask you to look at the graphs of H versus V, and more than likely, if this is on the AP test, it's going to be a multiple choice question, okay? And I think it is, I'm pretty sure, it's a multiple choice question for you guys too on your test, okay? So they're going to graph H versus V, and what they're going to say is, as volume increases, okay, as V gets, there's more and more and more volume, which is really the same thing as time increases. So sometimes when you look at these graphs, you'll see H versus time, okay? Graph the height as volume increases, or graph the height as time increases. If you have something like a cylinder, do you see, as I fill in this cylinder, like I just fill it in one layer at a time, and again, you have to assume that your faucet has a constant flow rate, okay? It has to be constant or else this is all messed up, okay? So you're going to assume that dV dt equals 5. Does that make sense? Or dV dt equals 3. It's a number. It's constant, okay? So if that's true, then do you see, as I fill in this cylinder, okay, every time I have to fill in a layer, it's the same amount each time, each layer, okay? So what's going to happen is, although my height is increasing, okay, it's going to increase at a constant rate. You guys good with that? And remember we talked about the slope of this is kind of like the velocity. My velocity is going to be pretty constant, okay, because I have to fill in the same area each time. But had I had a cone, think of the area as you get higher and higher. Do you see my area gets larger and larger? So I have more work to do. I have more to fill in each time. My surface area is getting larger and larger. The amount that I have, the volume that I have to fill in at any one time is getting larger and larger. And because of that, what's going to happen if you have a constant flow rate coming in, your fill rate is going to slow down. Does that make sense? Your dH dt is going to slow down. So what happens here is my slope, I'm going to get tired, right? My slope is going to get smaller and smaller and smaller. Does everybody see what I'm getting at? The slope is getting smaller and smaller. Okay, because I'm having to fill in more and more and more each time. It's getting bigger and bigger. Okay? All right. So if you have a picture like this, your barrel, okay, do you see what's happening here? First, my radius is getting bigger and bigger and bigger, my area. Do you see that? So I'm going to get slower and slower and slower. My slope here, okay, is going to maybe start out at 7, then go to 6, then go to 3, okay? But after I hit this middle range, okay, after I hit this height, do you see it gets easier? Not much easier, right? But my circles are going to get smaller. So I have to do less work to fill in each layer of water. So therefore, what's going to happen is, because it's getting smaller, I should be getting faster at my job. Does that make sense? Okay. And so here, the slope is actually going to start getting higher. 3 to 5 to 7, faster at my job. You guys good with that? Okay. So let's go to your worksheet, and what I'd like you to do is start filling it in. Okay. Match up your picture with the right graph. Okay. And what I'd like to do is maybe just do the first one with you guys. You guys okay with that? And then I'm going to let you guys work on your own, and then we'll check it when you're done. So if we look at this ink bottle, okay, do you see when I start filling this up, it's going to be constant. Everybody agree with that? The area is going to be the same, okay? So what's going to happen if I graph my h, my height, versus my volume, or h versus time, it'll be the same thing. What's going to happen is it's going to be constant at first. Okay, it's going to be constant. I mean, h would definitely be increasing, but it's going to be constant, okay? And then, right when I hit this level right here, do you see what's going to happen is I have less work to do. I have less of the area to fill. So should I work faster or slower? Faster. So my velocity there is going to go fast. So I'm going to head up. But it's going to be a curve. Head up. Okay, it's not going to be constant though, because the radius changes, so it's a curve. But then, do you see, once I hit this little neck right here, this is called a bottleneck, okay? So once I hit this up here, do you guys see that I'm going to go constant again? Okay, but guys, is this constant bigger or smaller than this constant? Am I going to go faster here or faster here? Faster here, right? So this slope should be higher. So what I'm going to do is make it a straight line, but definitely a slope that is higher than this green slope. And then I go look at all my choices, okay, and see which one matches best, and it should be letter G on this one. Okay, now I'm going to leave you guys on your own for a while. I'm going to walk around and help you guys out if you need help, and then we're going to come back and check this worksheet. You're going to find three graphs that don't match up to any picture, and for those three, I want you to draw the calculation.